Morning class. Today we're going to have a lecture on 7C, which is the expected value. This is kind of a new section for us, so it's probably going to be in two parts. I'll send both links. Expected value helps us determine whether or not we should play the lottery, or if we should buy a raffle ticket, or if we should buy an insurance policy. So, first example. You're given 7-to-1 odds against getting a sum of 9 in one roll of 2 dice. So that means if you do get a 9 in one roll of 2 dice, you win $7. If you get any other sum other than 9, means you lose the dollar that you paid to play. Okay? So I want to know how many sums of 9 there are in one roll of 2 dice. So you should be looking at your dice chart. You see I've highlighted it in pink. That's where the sum is 9, and there's 4 of them. Okay? There are 4. So how many sums are there in rolling 2 dice? That's 36. Remember, 6 times 6 is 36. So this is a sum of 9, and there's a total of 36. Okay? So this is when you win. This is when you lose. Okay? You have a probability value and a dollar value. Okay? So the probability of winning would be if you roll a sum of 9, and that's 4 times out of 36. And if you do roll a sum of 9, you win $7. Okay? So how many times would you lose? All the other times. That would be 32 out of 36. Okay? That's all the other times. That's rolling a sum of 2, 3, 4, 5, on up through 12, except 9. And if you lose $1. Okay? That makes sense? I hope so. And please notice 4 over 36 plus 32 over 36 equals 36 over 36, which is 1. So for these dollar games, you should get that 1. So the expected value formula is the probability of the first event times the value of the first event plus the probability of the second event times the value of the second event. I only have 2 events, 1, 2, so I only need 2 of these. Okay? So my expected value is 4 over 36 times 7 plus 32 over 36 times -1. Remember, that negative is at the bottom of your calculator, and it looks like that. Of course, you don't enter the parentheses. So when you take out your calculator, you're going to go 4 divide 36 times 7 plus 32 divide 36 times -1. And that comes out to be approximately -0.111. Okay? This is money, so we must convert that to cents. So that is, when I look at that for my rounding, it's -0.11 cents. Okay? The expected value is -11 cents. Okay? Turns out that the expected value is negative. That's how I say negative. And if the expected value is negative, any negative, 1 penny or 1,000 pennies, we do not play the game because the odds are against us. Okay? If the expected value is positive, anything from 1 penny on up to $100, whatever, then we should play the game. Okay? If the expected value is equal to 0, then it's no harm, no foul, it's fair to you, and it's fair to the house. Okay? So what you do is you set up your chart, you write your expected value equation, you calculate it, and then make an answer. No, do not play. Why? Because the expected value is negative. Okay. The next one is an insurance application. This is in your book, number 20. Okay? You own an insurance company, and you have to decide if it's worth it to sell a particular insurance policy to the masses for $600. Okay? So you get $600 from the customer. We can pretend I'm the company and you're the customer. So you give me $600. But at the same time, several claims are made on the policies. Now, I've sold multiple policies, so I have to consider all the claims and then do some calculation and decide if it's worth it for me to sell the policy to see if I would make a profit. Okay, so we have selling the policy. And then we have claims. You know, claims are like if you had an accident in your car, your insurance company would pay it out. So that's deducted from their profit. So again, we have the probability and the value. Well, the probability of me selling the policy, I'm going to say is 100%, which you know converts to just a plain 1. And I get $600 for it. Okay? But history has told us that one person in 50 will file a claim for $5,000. And that's money I have to pay out. So, to pay out, this becomes a negative number. So you have to be very careful to get that negative in there. Okay? History also tells us that 1 in 100 people will file a claim for $10,000. And again, that's money I have to pay out, so there's my negative. I also know that 1 in 200 people file a claim for $30,000. Okay? You know, their house completely flooded in the tornadoes. Okay? So that would be my setup. At this point, I need to write my expected value equation. Okay? And this time I have 1, 2, 3, 4 events. So I'm going to have 4 things. The expected value to the company, because this is a positive, is 1 times 600 plus 1 over 50 times negative 5,000 plus 1 over 100 times negative 10,000 plus 1 over 200 times negative 30,000. Okay, you're going to take your calculator now. Sorry. And 1 times 600 is 600 plus 1 divide 50 times negative at the bottom of your calculator times 5,000 plus 1 divide 100 times negative 10,000 plus 1 divide 200 times negative 30,000. Okay, watch your zeros. And in doing this, you find the expected value is 250. Okay, which is a positive number. So, for the policy that the company sells, that I sell to you, if I get $600 for it, I can expect a profit out of that $600 of $250. So that is a profit. So then you ask yourself, I ask myself, okay, I'm going to sell 10,000 policies. Okay? What would be my profit? Like State Farm selling across the country, 10,000 policies. So I take my 10,000 and I multiply that by 250, and that gives you $2,500,000 in profit because the expected value is positive. So this would be a good thing to do. If we were going to do it the opposite way, should you buy the policy, then this would be a negative 6,000. This would be to you, negative 6,000, and all these would be positives. But your book works with the company, okay? So I hope that you can understand that. I've assigned some problems for this. The next type, which will be in part 2, is a different kind of problem. It's called a recurring problem. So I'm going to set up for that, and I'll be back in a minute.